So here we have the working model of our wireless water level monitoring system using LORA modules. So I have chosen LORA modules of same specification, that is RA02 towards the top and bottom. So the top one acts as a transmitter and the bottom one LORA module works as a receiver. And while you are doing your project, please ensure that both the LORA modules are connected to antennas in order to prevent from the circuit damage. Right, so now so we are using two microcontrollers for each of the LORA modules to make it work, because the LORA modules will not work independently. They need a microcontroller to make it work. So microcontroller collects the data and it sends the data through wired to the LORA module, and this LORA module is configured to become a transmitter, and this transmitter sends the received data and it transmits the data in the form of wireless so that the receiver receives it, and it's after receiving it you can do some actions using the receiver side microcontroller. So my transmitting data will be the water level. So the water level is measured using this ultrasonic sensor, and after sensing the water level, I'll be sending the water level in the form of distance centimeter to the microcontroller, and the microcontroller sends it to the LORA module, and this LORA module and the transmitting side will be placed outside the house. Let's say that it's above the tank, and this receiving side will be inside the house, the receiving side LORA module, and this microcontroller that controls the receiving side LORA is placed inside the house. So after getting the data, I can make an alarm system at the receiving side, and also I chose this microcontroller for the reason that it has a LED display on it, so I can make use of the LED display to know at what level the water level has been filled. So that is the purpose I chose this R4 Wi-Fi module. So let's see the working. Let me power on the transmitting side. So now no lights are on. So once I turn on, we can see that this LED, so this is a indicator LED, this is an indicator LED on which we can see a blink. It means that the data packets has been sent wirelessly. So this LORA module sends the data in the form of data packets. Okay, so now at the receiver side, nothing is happening. So let me connect the receiving side. Let me connect the power to the receiving side. So once I do that, the receiving side also started blinking. So the transmitter side and the receiving side both started blinking. It means that the data packets has been successfully received to the receiving side. Okay, so now as soon as I powered the receiving side, I can see the LED display here. So let's assume that this is a tank, and here we have the water level. Let's say that is the 20% water level. Okay, so this, instead of making the water level to raise, I'm using this white sheet over here to raise. When I move it up, let's assume that the water level is being raised. So when I move it up, this sensor will sense it, and it will imagine that the water level is being raised, and it will show the display of the water level on this module. So let's see that. And I bring it gradually upwards. At one point, I got an alarm saying that the water level is full. At this point, I can turn off the water pump, or I can replace the tank. So this is how the project works. So let's see in detail about the circuit connections.
Okay, so these are the connections for the transmitting side and the receiving side of the LoRa modules. So as we discussed earlier that these LoRa modules should be operated with the help of an individual microcontroller. So towards the left, we have the LoRa transmitter that is being operated with the help of Arduino Nano. And towards the right, this LoRa receiver module is operated with the help of Arduino R4 Wi-Fi. Okay, let's come back to the receiving. Let's come back to the transmitting side LoRa module, where we have the ultrasonic sensor in order to measure the water level, and we have a transmission side LED that is connected with a current limiting resistor to a digital pin. And here the LoRa transmitter, it has around 8 connections. So actually this RA02 LoRa transmitter and receiver works with the principle of serial peripheral interface. So it's in short called as SPI, wherein you will be having connections like NSS, MOSI, MISO for data transfer, and SCK is for clock signal, and RST, ground, and the digital pin. So you need to connect it and connect these to the microcontroller. So when you compare the receiving side and transmitting side, you can see that both the connections of the digital pins are going to be the same for both. Right. So the connections are very easy, and also here you need to connect the ultrasonic sensor to the transmitting side. And to the receiving side, we have one more additional connection, that is the buzzer for making an alarm trigger. So now the for the Arduino R4 Wi-Fi, there is a sequence of LEDs on which we will be using it for displaying the animation for the water level. So we will see that in our project. So next we will get into the programming part. So here we have the program for our transmitter side microcontroller. So the transmitting side microcontroller controls three things here. One is the LoRa module, and the ultrasonic sensor, and the LED light, that is the indicator light. So you need to program for all the three. So here we start with including SPI.h, that is serial peripheral interface library, and the LoRa module library. And we declare some variables used in our project for the LED, and the duration and distance for storing the values for our water level distance. And here the trigger pin and echo pin is for the ultrasonic sensor to the pin numbers 3 and 4. That is the digital pins. And then we start the serial communication using serial.begin with a value of 9600. And then we make the trigger pin and set it to output, and echo pin to input, and the LED pin to output. Here, we start the LoRa by the function that is, if not LoRa.begin, 433 E6 means it's 433 megahertz. So uh, now uh, the microcontroller will check whether the LoRa started communication, or LoRa started sending the transmission. Now, inside the void loop, we make the trigger pin to be low and again to be high, and after a few microseconds we turn it low. In the meanwhile, while the trigger happens, the sound signal will be sent, So now I need to capture the sound signal received by it. So I get the distance with the duration of the received signal, and I need to use some calculation that is multiplied by 0.034 and divided by 2. It means that I need only half of the distance or the returning distance. So that is why I'm dividing it by 2. After that, I'll be using that distance to check whether if it meets the different water levels between 14 to 17 centimeter, 11 to 14, or 8 to 11, 5 to 8, or 3 to 5. So depending upon that, I will set the water tank percentage variable, integer variable, to be different percentage, that is from 20 to 100. So after that, any one of this checked value will be sent through the function called LORA.write unit 8 underscore t. So unit 8 underscore t means it's unsigned integer of 8-bit. Right. So now the water tank percentage value will be sent through the transmission. And then after that, first we will turn on the LED and then turn off the LED, so that after each successive data packet sent through the transmitter, it will first turn off and then it will turn on and then turn off when we end the transmission by using the function called LORA.end packet. For every 1 second, the measured value will be sent. So this is the program for the transmission side. So let's see the program for the receiving side. So the code here is for the receiving side. So as we need to display the water level as an animation, so I'll be using this Arduino LED matrix header file library that can be used for showing animation on our R4 Arduino Wi-Fi. So I'll be using these 2 lines here. One is adding the header file and then making an object for it. And then here, this is my animation that I have made. So I have named it as water underscore level underscore animation. So to make that animation, we have an online tool that Arduino provides us. So let's see how to make that. So this is the tool called LED matrix editor.arduino.c. So you can make any type of animation. So here for our project, I need to make I need to show something like the water level raises from 0 level to 100%. So first, I will make a horizontal phasing tag like this. So I just clicked on this pen here and I drew this. So if I want to erase something, I can use the second option and I can erase it. So this represents an empty tag. So once you create it, you will get an icon related to it, to what object we are now present. So I just, by being on that frame or object, I just click on this copy here. So it will make another copy. So I can make a 20% water level like this. Again, I click copy, then I make it 40, 60, 80, 100, and I'll just make something like the water's overflow. So now here you have some values in which you can give a time delay to check how it looks on your LED matrix. I'll make it 500 delay for each. So that you can make it run in a sequence of 500 milliseconds delay. Okay, now let's test it. I click the play button. So we can see our animation. Okay. So now once we have done our animation, you need to convert this animation into code. You need to select this third option here. So I click on that. I make a name called water level. I click OK. So it creates a C file with a .h extension. I can go to this folder, and here we have a C file. I click edit or open with Notepad. So this is how the program will look. So each individual blocks are in hex file, hex code. So each represents each frame. So I'm having 5 frames, 5 objects showing from empty water tank to 100% water tank. So 0, 20, 40, 60, 80, and 100% water level. So now I copy this entire thing, go back to my project here for the receiving side. So I click this 3 dots here on the Arduino IDE. I make a new tab in which I create a file called water level. As I've already done it, I'm just showing it how it's being done. I click, I need to give an extension. You should not forget an extension, .h, or else the ID will consider that this file is an INO file. That is the project file. I click OK. And here I paste program. Okay. So now I rearrange everything like this. I'll just do it for one. So this is for better understanding. All right. So now our first frame comes with a delay in our program. Similarly, you have the different frames at the bottom. So now after rearranging, this is how the code will look. I just made every array as an individual array of only one index. So that's how I made it. So I'll just delete the one that we have generated now. So I click delete. Okay, so coming to this water level animation. So I need to show this each animation during different levels of percentage that I'm receiving it from the transmission side, LORA. Okay, coming to this. So now these libraries that we are included is more or less the same that we used in the transmitter side. And here I'm making an integer water level. And now the serial monitor begins, and then the buzzer pin, I make a buzzer pin to show a alarm for our receiving side. And then the LoRa receiver starts with the 433 megahertz. I make a function called play alarm sound in which I make a buzzer to go on. And then inside the loop, this is for, I make a variable integer to receive the data packet. And if the data packet is received, then I make the LED pin go high, the indicator pin go high. And then I read the received data packet. And if the water level that we have received here from this address is equal to 20%, then I will load the sequence of water level 0. That is this one. Okay, the empty water level of 20%. Similarly, for 40, I'll be calling the next water level. For 60 for next water level, and coming to the 100%. So if it is 100%, I'll be loading this fourth water level sequence, and then I will play an alarm sound. And then after that, after every data packets that I've received, I'll make the LED pin to go low again. That it's an indication that we have successfully received the data packet from the transmitter. So this is how program is being done. So I'll be including all the project files in our in the description, so you can refer there and you can try it by yourself. And I think it's very easy for us to understand, and you can try it out. And if you face any troubles, you just post it as a comment and let's solve it there. Thank you so much, and we will meet again with another exciting project. Thank you so much.